Hello, I'm Constanza, and this is the workshop Introduction to Containers. Today, I'm also with Ville, Walter, and Elina, and we all work at Montel Intergalactic. Elina, you want to say a few words about Montel?
Yeah, so I'm Elina from Montel Intergalactic. I do recruitment and marketing at Montel. And what Montel Intergalactic is that we're a small software consultancy company. And if you want to know more about us, you can go to our website, montel.fi. And if you're looking for a job as a developer, let me know. I'm doing the recruitments, so feel free to contact me. But yeah, that's all about me and that's all about Montel. I'll let Coni continue from this on.
Thanks. So a little about the workshop. It will be between 15 and 17 p.m. If you have any questions about any moment, you can write in the chat and we'll have Ville and Walter answering the questions. And sometimes in the slides, there will be full screen container pictures, and those are like special moments where you can ask any questions that you have. These slides that I'm showing right now, they're open source, and you can search for them, reuse them, modify them. I modified them here. These slides in particular are in my repository, but the original repo is one. And if you check the slides on your own time, there will be some slides that have these extra details with this magnifying glass, but they're not like mandatory that you check that. So now onto the workshop. The first thing that we will see is like an introduction to Docker and containers and what they are. We will build our first containers and understand what Docker images are. Then we will start building Docker images and understand the difference between CMD and entry point, and also copying files into an image. Then we will see some networking basics, and lastly, some tips for efficient Docker files. So, questions? If not, we will keep moving. So, what is Docker? First, we will learn a bit about like the non-technical elevator pitch, like what you say to your boss when you want to start using containers in your development. Then the technical elevator pitch, like how does this help us as developers? How Docker help us makes our life easier, and a bit of history on containers, but we will not run any containers just yet. So, what do you tell your boss if you want to start using containers? First, let's see what has changed in the industry. 10 years ago or 20 years ago, most applications were monolithic applications that had very long development cycles. So we spent many months developing an application, and then this would go into one server completely dedicated to that application. And it was very difficult to scale, and it was also this single environment. And now we have the coupled service that follow microservices architecture. So we have many small services all running together in many different servers. We have very fast development cycles, maybe a week or 2 weeks. And we also have multiple environments. We usually have development, testing, staging environments. So this scales out very quickly. And deployment has become very complex because now we may have one application with Python and another with Java, and another is just the front end, so it's JavaScript. And we may have very different databases or many different targets. So how do we make all of this work together? So here there's like visualization of the problem that we have all of these different technologies and all of these different places where we want to deploy our services. So how do we match all of this up? And there's a parallel with the shipping industry. that we have all of these different things that we want to ship from one place to another, and they all have different sizes and different needs, like how to take care of them. And we also have very different ways of transportation. And how the shipping industry solved this was with containers, like physical containers. And the solution is that these containers are very standard, so we can stack them all in a big ship and send them anywhere, and we don't worry about taking care of the containers because someone else took care of putting the things inside. We just take care of moving the containers from place to place. So now the shipping ecosystem is much faster and efficient. And we can use the same idea in the container system for applications. So now we can package all of our applications into one standard unit, a container, and this container will be deployed to any different services, platforms that we need. So we eliminated this matrix. Now the solution to all of our problems is containers. And now a bit more technical explanation on why using containers is a good idea. Mostly because you escape the dependency hell. Now, if you write an application, you only need to write some instructions and write a script, a style script that will work for you. And if you put this script into a Docker file and then build a container from that, that container will work anywhere, and you don't have to worry about people running the container in a different operating system that may not have the same dependencies as you have or the same packages as you have. So you just have to write it once and it will work anywhere. So no more, it works in my machine, I don't know why it doesn't work in production. It also helps onboarding other developers easier into the project because they only need to download the container, the image, and run the container, and that's it. And they have the development environment set. They don't have to install tons of dependencies, and maybe they are conflicted and things won't work on their machine. And also it allows us to implement reliable continuous integration pipelines. So we can, if we merge a change into our Git repository, we can use GitHub or GitLab and build the containers from their pipelines. And we can build new environments like from zero with each change. And also we can build the container images as build artifacts. So we could even build images from every change that we make into the repository. So we will have a version of our application after each change, and we can go back. If there's any problem with the new change, we can just roll back to the previous image. Another benefit is that we can decouple the plumbing, like how our applications work together, because now we can just name, like, I want this container to connect to this other container, and we don't worry about their names or where they are or what they're running. We just tell it the name that we want to connect to, and it will work. So a bit of before and after Docker. Oh, just want to say here that there's more container technology than Docker, but Docker was the first to make this like accessible to all developers and easy to use. Like containers existed in Linux before Docker, but they were very complex to use. So now Docker made them easier and made them mainstream. So now like it's almost the standard in the development. So before Docker, there were no standardized exchange formats. So you could send applications like maybe a .zip or .tar or something else. Well, containers are like the original Linux containers are hard to use for developers. The components were not reusable. Like if I'm running a virtual machine, it's not so easy to send it to other developers to use. So Docker standardized the container format, and now everyone uses the same commands to work with containers. Containers are super easy to use, as we will see in the rest of the workshop, and they are reusable, so everyone can run the same versions. So if you want to ship an application before Docker, you, depending on your Linux distribution, you will need .dev or RPM or jar or use Homebrew. Maybe you will get conflicting dependencies and it will work only on your machine and not in your colleague's machine. And now they're all standard and you don't have to install any dependencies, so things will just work. So, for example, if I want to run a Java application in my computer, I don't have to install Java and all its dependencies anymore. I just will download a container image that has maybe a CentOS operating system, and it will have the Java runtime and some dependencies and the application itself, and it will work. So another thing that was different before Docker is that whenever there was a release, usually developers would package all their code in a tarball and give it to the operations team. And the operations team maybe wouldn't understand how to deploy this into the server, or you would deploy, but it wouldn't work as well as in the developer's machine. And the developers would just say, this works, so don't bother me. And it would be like a very painful process to deploy things. And now developers can just build Docker images and pass that onto the operations team, and the operations team will deploy that into the servers and just work because they don't need to install anything else. It's all packaged in the image. So now we will see a bit of our training environment. I hope that all of you signed up for an account at Docker Hub, because one option is to use Docker installed in your local machine, but if that's too complicated or if you didn't have time, you can use this play with Docker. You can go to this URL here and we'll get to this page that is on my right. So after it will ask you to log in with your Docker Hub account, and after you do that, you can click Start. And here you just click Add New Instance, and it will drop you into a terminal. And then we can run all the commands that we will use for this workshop session. So I'll just wait a bit for everyone to do that so you can follow along with the code that I will show. And if anyone has any problems, please write in the chat or ask any questions you have. So while we wait, I'll also talk a little bit about what installing Docker really means. Whenever you install Docker in your machine, what it really means is installer the Docker engine and the command line. The Docker engine is a daemon or a service that runs in the background in your computer. This background service is what runs the containers. And we interact with it using the command line, the Docker CLI. So the command line and the Docker engine communicate through an API. And since it's a standard API, there's lots of other ways to communicate with this Docker engine. So you could maybe write a script in Python that starts your containers, or Java, or any other language that has a library to use the Docker API. So for those of you that already have this working, you can write Docker version, and it would show something like this, like the information about your Docker installation. And like if you're doing this in your local computer, it should also show something similar. But if it doesn't work, please let us know. I don't know if Ville, can you maybe check if there's some questions in the chat? So, any other questions, maybe? Not? Then now we will start working with the first containers.
Sorry, Coni, I realized that just a second ago there was a new question. What was the command again, please?
Oh, yes, it's Docker version. So Docker space version. Like this. Okay. So now our first containers. So what we'll do here is first see Docker in action and start our first containers. So in your Docker environment, we will run this command, docker run busybox echo hello world. I'm gonna leave this slide here for a bit so everyone can take a look and write it on their environment, and I will run it on my terminal. So docker run busybox echo hello world, and this will just print hello world. Since our Docker environment, at least in the page, is brand new, we see a bit more of information here. This is just Docker downloading the image because we didn't have it in our computer or in our environment. And here, the last line that it outputs is the hello world that we run here. So what we did here, we used the busybox image, which is one of the simplest Docker images that exist. It's usually used in embedded systems like phones and routers. And we ran a single process in this image that just wrote hello world into the terminal. So now let's do something a bit more useful, like running an Ubuntu container. So for this, we will write docker run -it Ubuntu. We wait a bit for Docker to download the image. And now we are in another terminal, which is not the one that we were previously. Why did this happen is because we use the flags I and T. So -i tells Docker that connect us to the standard input on the container. -t tells Docker that we want to use a pseudo terminal. So now we have a command line into the terminal. It's as if we had an Ubuntu machine and open a terminal window there. So we can do things into this container now. For example, run this Piglet application. So if I try to run it, very low. It says that it doesn't find the command because it's not installed into this particular version of Ubuntu. So let's install it. And this is just common Ubuntu package style. First, we'll update on the packages. It will take a bit. And then we will install the Piglet package. Okay, install. Now we wait. Oh, we don't have to wait. Interesting. Let's see what's going on. probably a typo. So now we install the Figlet package, and now we can use it for Figlet hello, and it will print a very big hello.
Sorry to interrupt, Coni, but people are asking in the chat if the screen could be a bit bigger because they can't see what you're typing.
Yes, let me try something. There.
There was also quite a many people saying that they had a problem starting out, like they couldn't find the address didn't work for them. Ville provided another address, but I think people some people are still a bit lost. So please, if you have problems, just write in chat or let us know by saying that, hey, I'm in trouble.
Yes, we can also go back. No problem at all. So here, so if you just got the terminal working, you can write Docker version and it will show you the Docker information. Maybe I'll also write these comments in the chat, so if everyone needs to catch up.
Yeah, that's a really good idea. Someone is also asking about what was after Docker version.
Yes. So I will write in the chat all the comments that we have used so far. So first Docker version, and then we run visibles. Oh, I think Kirsty, I hope I said that right. I think it's Figlet with a T at the end instead of a D. Now, we also run an Ubuntu container. And inside that Ubuntu container, we try to run Figlet hello, and that will say that the package doesn't exist, so we will need to install it. First, we update the repositories, and then install the package. And now you're all catch up, and we need Figlet hello. I'll just keep the chat here, so I'll be able to read the comments. Okay, so I hope everyone was able to catch up. Oh no, I just realized I wrote everything from one person. So let's write everything again. Sorry.
No worries. I think it's this is good time for everyone who's lost to catch up a little bit.
I'm just writing the comments in the chat, so that's why there's lots of typing but not talking. There. So now we move on. Now that we are in an Ubuntu container, we can also check what packages we have installed. So we can write this command that will tell us how many packages do we have installed. So in my environment, there's 98 packages installed. And now we can check how many packets there's in our host. So not inside the container, but in the machine that we were originally writing the commands. So to exit the container, we just press Ctrl D or just write exit. And now we're back into our normal terminal. And if we try to run that packet, like the command that tells us the number of packages, it doesn't even have the command to count the packages. So we can clearly see that we were in a different environment than in the Ubuntu container. And if we try to run Figlet here, it also doesn't exist. So why does this happen? It's because the Ubuntu container is independent from the host operative system. So even if I'm running maybe Windows or Mac or any other Linux distribution, it will be completely separate from this Ubuntu container that I run. So anything that I install in the container won't be installed in the host that I was using, and vice versa. If I install anything in the host, it won't appear in the container. So this helps in that we can run any container in any host. So except for running Windows containers can only be run in Windows machines, but you can run a Linux container into a Windows machine without any problems. So if you are maybe working with Windows and need to do some development for Linux, then you can just write or use a Linux container. So now, for those of you who were able to get the container running, what happened with that container? It's now stopped, still exists in our machine, but it's not running. And all of its resources, like its memory and CPU, were freed up for the host to use. So, and we will later see how to get it back. But for now, let's start another container with the exact same command as before. So docker run -id ubuntu. And now we get the terminal, and it didn't show all the extra text because the image was already downloaded. And let's try the Figlet command again. And again, it doesn't exist. So this is because we started a brand new container, and it's different from the one that we were using before. And containers are also independent from each other, so they don't share any resources. Question. I think there might be many questions. No. The -id is so that the I says that Docker to connect us to the standard input, so that everything that we write will go to the container as the input. And the T is that we want to use a pseudo terminal. So, and that's the combination of those two gives us this like command prompt where we can write commands. If we didn't do that, we wouldn't have this like to write. Someone asked, so each time we run docker run -id ubuntu, a new docker is made? Yes. So each time you run that, you will have more and more containers. The timer is because since this is a free resource, the Play with Docker page that we are using, there's a limit of 4 hours that you can use, but this workshop won't be longer than 2 hours, so that's fine for us. But if you're ever working with this just for fun, after 4 hours, it will delete your session. Okay, so let's move on. Background containers. So the first containers that we ran were interactive. We were able to write comments in the container and get feedback on that. And now we will see how to run containers that are not interactive and run in the background. So we just let them run and then we can do some other things. So first, I will exit this container that I have opened. And now we will run a new container. So, forgot the page here, yes. Docker run on this new image. Log. And what this container does is just prints the time every second. And it will do that forever unless we tell it to stop. So now I'll just stop it with Ctrl+C because I don't want this to run forever. And there's a few new things here, like for example, well, Docker again downloaded the image, but now this image has a slash in it. And it's not like the Ubuntu image that was just Ubuntu. This is an image created by a user, so JP that's a user. And we will talk a bit about user-created images later. For now, let's try to run this container, but in the background, so it won't use our terminal when it's running. So it's same command, but we also add -d. Run. And now it seems like nothing happened, but actually what is happening is the container is running in the background. So it keeps printing the time every second, but we cannot see it. But Docker collects the logs. So if we ask Docker to give us everything that the container has printed, we can see it later. But first, how we can check that our container is still running? So we can use Docker PS. Oh, you can exit with Ctrl+C. No, we downloaded the container. Here are the lines where Docker downloaded the container, and all these images are stored in Docker Hub. So if you ever need to download a new image, it will be downloaded from there. Yes. So now let's run Docker PS. And it's a bit messed up, but it's showing one line, hopefully, with the ID of our container that Docker assigns automatically, the name of the image, the command that the container is running, and some statistics like when it was created and what is the status. So now it's up about a minute ago. So we can run 2 more containers with exactly the same command as before. So I'll just let them running. And if I run Docker PS again, now it shows there's 3 containers alive. One about a minute ago, one 4 seconds ago, and one 7 seconds ago. And they're all running the same command, so they're exactly the same, but they are independent from each other. Sometimes this list, like if I have many containers running in my computer, this list might be very long. So you can use -L to just see the last container that you run. So and then it will show us only one that now says 43 seconds ago. We can also ask Docker to just list the IDs, like if this is too much information for us. And for that, we will use -q, Docker, and it just prints the IDs. So I also copy this in the chat. We can also combine these flags, so we can ask Docker to show. Oh, sorry. There. So, for example, if I combine L and Q, it will show the ID of the last container. So now I told you before that the containers were running, but I'm printing the time every second, but we cannot see it. So let's try to get that back. So we can use Docker logs, and here I won't be able to just paste this into the chat because we have to tell Docker which container we want to check the logs of. So here I have 3 and I only want this first one. So I just write the beginning of the ID. So in this case, the full ID is 855C97DB0D37, but that's too long. So I will just write 855, and it prints all the times that the container has printed. Very long list. So if you ever need to see what's happening with your container, you can use this command docker logs and tell to Docker which container you want to check. Maybe we want to only check the last few lines of the output because this is just way too much. So we can also use the tail option. So tail 3, for example. Logs, tail 3. And 855 was the beginning of the container ID. So, and this will just print the last 3 lines that the container has printed. We can also follow the logs in real time. So if we want to really see what is happening, so for that we use the option follow. So very similar to the previous command, we just add this new option. Docker logs tail 1. So I will print 1 line from the current output. And now follow 55. So now it first printed 1 line because we asked for tail 1. And now it's as if I'm watching the container in real time and it's printing at the same, like this is what the container is doing right now. And I can use Ctrl+C to exit this. And here you may think that the container was stopped, but what we really did was just stop looking at the container logs. So the container is still running in the background, we just stopped looking. So if we run again Docker PS, we see that our 3 containers are still there, and they will keep being there unless we delete them. And we can kill the container using Docker kill, or we can just stop it with Docker stop. Docker kill sends a kill signal to the container, so the container stops immediately. It doesn't matter what it's doing. The second Docker stop only sends a term signal, so it will tell the container like please stop, basically. And you will wait 10 seconds for the container to stop. And if the container doesn't, then it will just kill it. So let's stop one of our containers, maybe the first one. So Docker stop and the ID. And in my case, that's still 855. So we wait a bit. But it seems that nothing's happening, so Docker is going to kill it soon. And now it's stopped. So now if I do Docker PS again, it only lists 2 containers. There are the other 2 that I didn't stop. So we had to wait a bit for this container to stop, and now we won't want to do that, so we will just kill them. So now it's just Docker kill and the beginning of this. I can send a link at the end to the slides. Yes. So now I sent a kill signal to my containers and it killed both containers. So now if I use the RPS, there's no more running containers, they're all stopped. Even though the containers are stopped, we can use the option -A, and we will see all the containers that we have run but are in the stopped state. So they still exist in our machines, they're just not running. And any of these containers that are stopped, we can restart with Docker start and the ID. So we could, for example, take the 855 container that we'll be using all this time and start it with Docker start. So now if I do Docker PS again, but not all together. So now the container is running again. Questions? I hope not everyone is totally lost.
Hey, please don't be shy to say to Coni if you're totally lost. That's okay. We will help you back on board if that happens.
Yes, we will go back in the slides, anything you need.
All good here, at least I'm playing with the Docker.
Yay. And also, if you have any other questions that not necessarily with the comments already, but if you have questions about how Docker works, you can also ask them. So Mila is asking, what's the difference between Docker run and Docker start? Docker run tells Docker that we want to start a brand new container, and we can give it some options that we're not seeing in the workshop because they're a bit more advanced. And Docker start tells Docker we want to restart a container that we already ran before. So you cannot run Docker start if the container doesn't exist yet. But you always first need to Docker run to bring it to life. And then if you stop it, you can run Docker start. Can you clarify this question about the most common container, like the one we're using in this workshop or in general? Well, in general, it really depends on what you're doing. Like, For example, in my work, I use a lot of Python. So usually the containers I run have Python installed. So they're usually just named Python. And maybe if I'm working with another language, I will use a container that has that language installed. But it really depends on what you're doing. Maybe Billy and Montel can also comment on what the most common container is for them. Okay, so I think we can move on maybe. Now we'll stop talking about containers a bit and we'll talk about Docker images. So what is a Docker image? And we'll also see what layers are, what the namespaces are, and how to search for images. So first, the image, a Docker image is some files and some metadata. Right. So these files in the image form like the root file system of our container. You can imagine that in the Ubuntu container case, the image has all the files that Ubuntu needs to be able to work. So, and the metadata that accompanies the files can say things like the author of the image and or what commands to execute when the container runs, what environment variables to set and stuff like that. So a Docker image is made of layers, so and they're like stacked one on top of the other. And each layer can maybe add, change files and metadata. And the images can share layers between them. So this optimizes like how much space they use. We will talk about that a bit later. So in the example of a Java web application, each layer of the Java image, like the first layer would be the CentOS base layer, that the operating system that container uses. Then some packages and configuration that we add or the IT team adds. Then another layer is the Java runtime. Then another layer is Tomcat. Another layer is our application dependencies. Another layer is the application code. And the last layer will be the application configuration. This is just an example because every Docker image is different, but this is more or less like how they all work. And what's the difference between a container and an image? The images is just a read-only file system. We cannot modify an image. And a container, on the other hand, is like a set of processes that are running in the computer. And they're read and write, like we can make modifications onto the container. So from an image, when we use Docker run, we are basically saying that, okay, now we want to be able to make changes into this file system. Yes, that is the picture. So since all the images are made up of layers, and many like containers can use the same image and different images can use the same layers. So it's like it's all built on top of each other. So we already saw that, for example, we had multiple clock containers and they all start from the same clock image, but they were different within them. So we can also make kind of a comparison to object-oriented programming. So in this case, like an image is similar to a class, and the layers are similar to inheritance, and the containers are similar to instances. So each container is like an instance of a Docker image. And I said before that we cannot change Docker images. So how do we create new images? Like if we have new requirements, how we create these new images for new containers. So what we do is, one way of making these new images is start a new container, make changes into the container, and then save an image from that container. So it's like we're taking a photo of the container after we made all the changes. And that will create a new layer with the changes we made. So and now, if the only way to create an image is from a container, but the only way to create a container is from an image, how did containers start? And there's a special image called Scratch that doesn't have anything, it's just like the base. So all Docker images, if you go back far enough, they'll all start from scratch. But usually you don't really need to use it unless like maybe an advanced user needs to use it, but from day to day as a developer, you probably won't need to. So you just need to use the images like that you download. I mentioned that we can make changes into the container and save that into an image as a photo. And the command to do that is docker commit. So this will save all the changes into a layer. But there's a more effective way of creating images, which is docker build. And that's what I think almost all developers use. So this runs like a repeatable sequence of commands and then creates the image. And we will see both. I also mentioned before that there was a difference between the Ubuntu image and the clock image. Oh yes, great idea. Maybe we can have a break, maybe at 4 for 5 minutes or 10, I don't know. Elena, what do you think? I will keep explaining this for now, or no?
Sorry, Coni, I missed what you asked.
Oh, someone is asking if we could take a break, and maybe that's a good idea. So what do you think, 5 minutes at 4?
Yeah, that sounds good. If people have to go to toilet or something, then yes. Yeah, I think we have time for that.
So I'll keep going until 4 and then we take a break. So about naming images, there's official images, for example, Ubuntu or VisiBox, and those are just the name. I mentioned that, for example, I use Python images, and those are also just named Python. There's also user or organization images. So this user created the image clock, and because it's not an official image, it has his name as part of the name. And we can also self-host images. So all of these previous images live in the Docker registry, and that's why they don't have a URL. But maybe in my organization, we have our own place to save images, and then we will use our own URL here, and then the name of the image. So yeah, like I said, the official images are stored at the Docker URL, and they usually maintain all the official images. And here, in the case of the user image, the Docker Hub user is this name, and the image name is just clock. So, and in the case of the self-hosted namespaces, if anyone, for example, the organization uses Google Cloud and you save your Docker images there, the full name of the image would be first the Google Cloud registry, so gcr.io, then Google Containers, because that's where Google stores containers, and then the name of the image. So where do we store images? As said previously, images can be stored in a Docker registry or in your own computer. So if you create an image in your computer, it will only be stored first in just in your computer. And if you wanted to have it available for everyone else, you have to push it to either the Docker registry or some other registry. Before going into the break, we can see what images we have now. So for that, we run Docker images. All right. And these are the 3 images that I have downloaded so far. So the VisiBox was the very first one, the Ubuntu image, and the cloud image. We can download images in 2 ways. There's Docker Pool, and if we use, like, for example, Docker Pool Ubuntu, that will only download the image and won't do anything else. And whenever we run Docker run and the computer doesn't have the image, it will also be downloaded then, like on demand. Yes. So for example, we can use Docker Pool Debian Jesse. And this won't run any container, just download the image. So now it's downloading, but didn't do anything else. So now I think it's a good time for the break. And let's see everyone back at 4:05. We'll stop sharing. And also, if anyone wants to stay and ask questions, that's fine too. I hope everyone can see everything again. So the last thing that we did before the break was to download it on pulling a Docker image, in this case, Debian image. And here we also added like this :Jesse. And what this means is that we downloaded a particular version of the Debian image. So images can have tags, and tags are these text that comes after the colon. And tags define versions or variants. So the default tag, if we don't define one, is latest, which will refer to the latest image created. But there's occasions when to use or not use tags. Like if we're just playing or testing, we don't need to define them. Or if we just want the latest version, we just don't write it, and by default it will download the latest. But if maybe we're going to production and we need to set the version, like this is version 2 of our software, then we should define a tag so that we can go back to that later, because each latest version will override the previous one. So we lose access to that version if we don't define a tag. I don't know if anyone has questions. Now comes the part when we start building images. So first we will build image interactively. And for this, what we want, like our goal here, is to create a Docker image that has the Figlet package already installed, so that whenever we want to run it again, we won't have to first install it. And the plan for that is we will create a container from an Ubuntu image as before, and just as before, we will manually install the package, and then we will. So we will also learn a few commands along the way. Oh, and here's the plan that I just said. So first, we will again run our Ubuntu container, just as we did before. So Ubuntu. And again, we are inside the container. Just as before, we will first update all the registries. Okay. install the Figlet package. So far, nothing new. But now we will first exit the container. So just write exit. And remember that this doesn't delete the container, it's just in a stop state. And we can run docker diff and it will tell us what the difference is. So first I will just fetch the ID of my container with docker ps. Again, 855. And now I can docker, oh no, but this is a different container, sorry. So since the container is stopped, we need to use the -a option. So now I will look for the Ubuntu one, and here is the new ID, so p03. So now I can run docker diff and give it the ID. So, and this shows many things, but the important one is that now there's the Figlet package. So it shows that the files on the container change, like they're not the same as just the Ubuntu image. And the change is that we installed the Figlet package basically. So now Docker is basically showing that what we did. And we can use this like as an audit way, like to see what changes were made. But we usually don't do this, and because we just start creating images from Docker files, which we will see later. So now the interesting part is we can turn this container into a new image. And for that we use Docker commit. So we use Docker commit and the ID of the container. In this case it was p03, so Docker commit p03. And it gives me a hash, and this hash is the identifier for the new image. And we can use this new image to run a new container. So let's run this. First, I'm going to list all my images to see what its ID is. And there's this one image created 20 seconds ago, which is the one I just created. And here is the ID. So now if I do, going to copy this in the chat. Then, so now Docker IT. Now instead of giving it Ubuntu, I will use the ID of my new image. So this long thing. And now I'm again into a container terminal, but now I can just try to Figlet hello. I don't have to install it anymore, and it will work. Ta-da! So we just created our first image. I had to look up the ID of this image, and it's a very long number, so it's not really convenient. So we will see now how we can name or tag our new images. So I will exit here first. And now I can use Docker tag. That's the command to rename images. I'm also gonna copy this into the chat. So first I give it the ID and the new name I want my image to have. So now if I do Docker image, just Now instead of being none, my image has its own name, which is shown here. And I can use it to run containers too. So docker run -it finger. And I can repeat hello again. And it works. So now we have created an image that has the field package. This was like a very manual process. Like we had to first download the base image, run a container from there. Oh, please ask if you got lost. Like I can also go back if you need. Okay, let's go back to committing the image. So what we have here before, we run a Ubuntu container with this docker run.it Ubuntu just as before, and we install the figlet package, and then we run docker commit, and that created the new image. Yes, so commit is used for making the image. So if you use docker commit and the ID of the container, you will create a new image. So, and the fillet image that we just created is a local image in the computer. It doesn't exist in the, or maybe it does, like maybe someone uploaded it to Docker registry, but in theory, it just exists in our computers. Oh, Mila, I think maybe you need to exit the container. You can write exit and then try to run Docker commands. So everything okay with the commit command, or does anyone still have questions? And then we can go through the tag command. So what we did later is that when we ran docker commit, we created a new image, but it only had the, okay. So maybe I'll just run all these comments again. So here I did docker commit and the ID of the container. And if I list all my images, there is a new image created 5 seconds ago, but doesn't have a name. So if I want to name it, what I need is the Docker tag. And I think if anyone is stuck, maybe they're inside a container. So make sure that you're seeing this like red and green prompt. And here, when I want to tag an image, I need to give it first the ID of the image that I want to tag, which is, for example, this or this or this, and then the name, the new name that I want to give it. So here I create a new image, and now I have the image name field. I hope everything is clear now. If not, please just ask. I don't want anyone to leave here totally lost. Okay, so some people are still having problems. I think maybe what's happening is that you're inside a container. Like, for example, if you run, yes. So if you're inside a container, like, and you're seeing this, like this hashtag at the end, then you will need to exit the container with writing exit, and then you can run again all the Docker commands. Yes. There's some special container images that have Docker installed, and then so you can use Docker inside a Docker container and just go like infinitely inside your containers. But here our containers don't have Docker, so we can only run it like on our development machine. So the last thing that we did was to rename our image from its ugly ID to a new name, Piglet. And all of this is a very manual process, and as you can see, we can also maybe make mistakes or forgot like what the ID was, so it's not very repeatable. And for that, there's an automated process to build images, which is the preferred way. But also pause for questions. So the automated way is building Docker images with a Docker file. So we will again build images, but first we will write a Docker file and then build an image from that Docker file. Docker file, simply put, is like a recipe for a Docker image. So it's a series of instructions that we can Docker first do this and this and this, and this will build you an image. And there's a special command, Docker build, to build these new images. And we will see all this now. So first, we will write our first Docker file. And for that, we need to create a new directory. So outside your Docker container, so in your local or this web interface, create a new directory with nkdir. And then we cd into the container. Oh, sorry, into the directory. My image. And now we will create a Docker file. I think if for everyone that's using this web interface, we only have Vim here. But if you are in your own computer, you can use any editor you want. I hope we will all be able to exit afterwards. So now I'm in the editor and I'm writing my first Docker file.
Your chat window is on this Vim editor.
Oh, yes. Maybe I'll close this. So for everyone that's not familiar with Vim, when you first enter, you need to press I to write, or else you won't be able to. So I, and then you won't be able to.
You need to press what?
I. So just the letter I. And then you will see on the bottom that there's insert, and that allows you to write. So, and into this file, we will type all these 3 lines that maybe I will paste in the chat. So, and each of these lines is one instruction. So first, the from line is usually the first time in any Docker file, and it says tells Docker from which image we want to build our image from. And just as before we started running an Ubuntu container, here we won't run the container, but we still want to start from an Ubuntu image. The second line tells Docker to install, to refresh the repository so that we can install the packages later. So these are the same commands that we are running in the container. We're just writing them down to a file. And we're also using these special instructions like from and run. So, and each of these run lines tells Docker to run all of these as a command. And one important thing is that these commands cannot be interactive because this all runs automatically. So we cannot give input. Like if the command is asking, do you want to confirm this? You won't be able to confirm. So they need to be like, for example, for this install, we should also add the -y, and so that it all auto installs and doesn't ask like, are you sure you want to install this? So we're going to save our file and exit the editor. And this is the complicated part. Oh yes, thank you for sharing the Vim cheat sheet. In any case, if now we will do so now I will press this. So first escape, then :QW, and that will save the file, and then enter. Oh no, sorry. WQ, and write that quickly into the chat. And now we should all be back into our terminal after editing the file. And finally, we will build our image with Docker build. So it's important that we are in the same directory where our file is. Otherwise, Docker won't know which file to use to build the image. So, but we are in the same directory, but for the future. So Docker build dot. And before I run it, the -t tells Docker what's the name I want to give this image, so it won't have just the ID. I give it the name immediately. So here I'm telling that the name is Piglet, and the dot indicates that I want to use the directory that I'm in to build the image. Yes, exiting Vim. Mary, I hope I said your name right. I think you have a typo in the Ubuntu name, and that's why it's not downloading. And to exit Vim, first press the escape key, then write a colon, then W, then Q, and then press enter, and that should exit Vim. So for now, I will just press enter here. And I wrote it wrong. Build, not build. So what it's doing now is we have the same output as if we had run this by hand, but it's doing it by itself. But now it says that it successfully built the image and it tagged or named it Figlet. And here we see like it ran our Docker file step by step. So here's the first step, like from Ubuntu. Then step 2 here. So they run apt-get update. Then step 3, install Figlet, and the output for each of those commands. But before that, it also sends the build context to the Docker daemon. And what that means is that it sends all the files in the directory to the Docker daemon. So we will see also this a bit forward in the workshop, that if I have files that I want to copy into the image, then I also need to have them in the same directory so that they will be sent to the Docker daemon. But don't worry, because we will see this later. And then, as we saw, it executed step by step. So this build process can be really long. If your Docker file is super big, so it can take a long time. Now, if we, yes?
Coni, I'm sorry to interrupt again, but I see that from the chat, still some people have some issues exiting the Vim.
Yes. This is always a problem for me too. Like I always have to Google first how to exit Vim, so don't worry if you're stuck.
The exit Vim problems. So did you press ESC ja sitten kaksoispiste W ja U ja Enter.
Does anyone still have problems with exiting Vim?
At least Nora is saying that nothing happens when she hits ESC.
Oh yes, now it works. Great. So what we did in between was building the images, and I was just explaining how the building worked. And for that, I will just send the command again in the chat so everyone can catch up. So, and for those of you that already built the image, if we run the same command again, let's say that we, for some reason, want to rebuild the image, it's almost instantaneous, and we didn't get such a big output as before. And this is because Docker saves, like each time you build an image, it saves in the cache or the things that it did. So if you want to do it again, it doesn't really do it again and just looks for what it saved the first time. So each successive build will be almost instantaneous. But for this to work, it needs to have the exact same instructions in your Docker file. So if the Docker file changes in between, it would again run everything and you will get this super big output. So you need to make sure that your image is written so that the things that changes only goes at the end, because then Docker can use, like, first steps will all be the same, and it doesn't have to do it each time. And it will only do the last few steps. So I will just demonstrate this really quickly, but it's not necessary that you follow this. So I'll, for example, modify the Docker file, and now I will install Figlet and Causate. So I will build the image. And now, since it's different, as like I modified the line, it had to install everything again. But if I do it once more, then it doesn't do anything. So it's really important that you take care of how your Docker file is built so that you can minimize this. And now we just build the image and we still haven't run any containers from them, and let's run it now. So again, same old command. So again, I'm inside a container and I can run the Figlet command and it would work. So we got the same as before, and container that can run Figlet without installing it, but now we did it from a Docker file instead of doing it manually. Does anyone have questions so far?
Hi, I asked quickly, can I have several Docker files in the same directory, or is it important that I only have one Docker file there?
No, you can have different Docker files, but Docker by default will use the one named Docker file. So if you wanted to use a different one, you have to tell the file like manually. So, and that would be Docker build-f and the name of the Docker files. For example, I don't know, the Docker file. And then the rest of the options.
Thanks.
Any other questions?
Riikka is also asking in the chat, can you show the edits you did in the Docker file?
Yes. So what I did was I added the Causate package to the installing. So now instead of installing the Figlet package, I also installed the Causate package. This package is only like print things to the screen, so they're not like super important packages. It's just like for demonstration. So okay, so now let's go on. Now we will talk a bit about two very important keywords in Docker files, and they're very confusing. So the CMD and entry point keywords allow us to set a command that the container will run by default. So when, for example, if say we want to publish our Figlet image, we would like to some people can run it and they don't have to go inside the container to run the command, and the container instead would just print the message by itself, just like the clock container printed the time without us doing anything. So the command that we want to run will be this Figlet-f script hello, and what it does is just printing a much fancier hello. And for that, we need to add a few things to our Docker file. I also paste that into the chat. So we will almost complete half of the Docker file. So instead of one of the changes that I will explain a bit later is now we will put this into JSON syntax. So this will be into brackets and each word goes separately. And we will add a new line, this cmd figlet. So, and this is the command that we want to run that will print a fancier hello. So what the cmd line does is tell the container that when it's run, it has to run this command. But only the last, like if I have many CMD lines in my file, only the last one will take effect. So usually we only have one, and it tends to be at the end of the Docker file. So it's like after we did everything that we had previously, lastly run this command. So now we exit again. And we will build the image with the same command as before. So docker build -t figlet. And we wait a bit. And now we can run the image. And now, different as before, we don't have to give it the -it options. We just run the container as is. So only docker run figlet. And it instantly prints the hello, fancier hello. So, and now we didn't have to go inside the container and write the figlet hello command ourselves. The container did it alone. There's also a way that we can override this command. So even though our container can run this figlet hello by itself, maybe we still want to go inside to do something else. And for that, when we run docker run in the IT option, we give it the command that we want at the end. So if you see here, after the figlet, the image name, we give it bash. And what that does is that Docker will run bash inside the container and give us a terminal as usual. So but now I'm back at how things were. I'm in a terminal inside the container. So what I did was override that command that I added into the Docker file with this bash command. I'm going to exit the container. And maybe now we would like that people can run our container and just give the container the word that they want to print without giving it the figlet command. So as in shown here in the slide, if I run a figlet salute, it will print salute. And this will need to be like, it can be any word that the user wants. So how can we do that is with the entry point keyword. So now we will modify our Docker file again, and I will copy this into the chat. So So now instead of the CMD line, I will have this entry point line. And just as before, I will write this into brackets. So it's similar to what we had before, but we no longer have the hello at the end. We just tell the Figlet and the script to print it, the fancy version, but we don't give it the word to print. And the other difference is that we have this into brackets. And why we're doing that is because everything that we run without the brackets, like for example, this on the second line, the get update, gets run into a shell. So what Docker does is run a shell, and inside the shell run that command. And sometimes that's not what we want. Maybe we want to run the command directly without the shell, and writing it between brackets, like which is called JSON syntax, that doesn't allocate the shell. So it will just run the command directly. So as shown here, it would wrap this into a shell and the command wouldn't really work. Shell syntax, which is the second line, the one that doesn't have the brackets, it is easier to write, but might get into problems if we don't need to allocate a shell or if our processes need to do some special things. So even though JSON syntax is harder to write because you have to like put everything into brackets and ticks and stuff, then it doesn't have that extra process, so you can make sure that the container is running what you actually want it to run. So now that I made these changes, I'm going to exit again. And I'm going to review the image with the same command as before. Oh, the double quotes are part of the JSON syntax. So what we were seeing before that, if I run it without the brackets and the quotes, it allocates a shell, and maybe we don't want that. So it's usually much safer to use the brackets and the quotes. So now we build the image. And that was very fast. And now we run the image. And I will give it the salute word. And my container, remember that we had given it the Figlet command, but without the word. So now we are giving it the word now. And it prints the word. And I can give it any word that I want to the same image. So for example, hello, and it prints hello, or I can give it my name. So because we didn't give it the full command, just the beginning, so Figlet -f script, and we left the word outside. Whenever we run the container, we can give it the last part of the command. So what it's doing actually is that Docker takes this command and gives it to this entry point command, and that makes like the command complete, and that's what Docker runs. If I try to run this without a word at the end, it would probably fail. It doesn't do anything because I didn't give any word, and maybe I want to give it a default word. So if I don't write anything, it will still print something, but I can also change that if I want. And for that, we will define both entry point and CMD. And they both need to have this JSON syntax. So we will edit our Docker file again and add this new line CMD. So CMD, hello world. So here CMD is kind of completing the command that I'm giving an entry point. So what the container will run is actually all of this plus this at the end. And it will print hello world if I don't run anything else. So save this, build the image. Remember that anytime that you change the Docker file, you need to rebuild your image. And now I can run this container. And I didn't give it any word, but I still print hello world because that's what I put in the Docker file. But I can also change what it prints. So whenever I add something at the end, I'm overriding what I put in the CMD line, but I can't override the entry point line easily. You can do it if you know like some more advanced Docker options, but from this, you cannot do it yet. So we can also override it and give it some other words that we want to bring at the end of the command. So and here is how you can override the entry point. Like, again, what if we really want to have a shell or a command line into the container? We can override entry point. So now what we will do is add the -- entry point and give it a new command to run. So instead of running Figlet, it will run, in this case, bash. And again, I have a command line into the container, just as I did from the beginning. And I will exit. Does anyone have questions? And I think maybe we will end the workshop here because it's already 4:50 and I don't want to go over 5. So if you have any questions at all, it can be also from things that we didn't see in the workshop, but just any general Docker questions that you have.
There has been great questions in the chat. I hope everyone who has asked something there has got a response. At some point there were quite many questions, but I think all of them were answered. But if your question wasn't answered, please ask again.
Yes, I think Walter is doing a great job answering all the questions.
Yes. Yeah, big thanks to Walter and Ville for answering the questions. Coni, can you see Milla is asking in the chat? So if you had an existing Python program, for example, how do you get that in a container?
Well, we didn't get to see it, but if you can maybe check the slides later or check the Docker documentation, there's also a special in the Docker file, you can use the word copy, and that will copy all your files from your computer into the container. So you can tell it to copy a script, for example, and then you will have that script inside your container when you run it. And you could give as a command Python at the name of your script. So the container will run the script when it starts. Maybe I will stop sharing now, but I will start sharing some links into the chat. So I can do some Googling and also share links. So there, let's turn the link for if you want to use your own files into containers. And there's a lot of examples there too.
I have one more thing that I wanted to mention. Sanna from Mimmit Koodaa told me that there will be some kind of maybe a link when you leave the Zoom, or then it's sent to you later on. I don't know how exactly it works, but you should be able to give feedback to us about the workshop, and it would be really nice if you take a minute or two to give us some feedback, so we know how you felt about the workshop.
Yeah, I hope everyone was able to follow. I know that sometimes I can speak really fast, so if you have any questions now, you can also ask them.
Reeta is asking there, what is the best way to practice?
I would say just running as much containers as you want. Like, maybe if you know any programming language or you already have some programs, try to run that into containers and maybe see if anyone you know or your friends can then run the containers in the computers. So whatever you have, you can put in a container. So, and there's containers for everything, I think. So if you're maybe a front-end developer, you can run your front-end in a container, or if you're a back-end developer or anything, you can containerize everything. So the sky is the limit.
Someone is asking, would it be possible to, oh, now it's moving fast. Would it be possible to organize workshop on how to add Docker container image to an existing project? And maybe how to add tests to that?
Definitely, I think. Maybe if not me, someone else at Montel. I think everyone at Montel knows about this, so we could organize another workshop.
Yeah, I will take this idea and share it in our company Slack and ask if someone has time to organize that workshop. Thanks for the idea.
So yeah, it's almost 5, so maybe we should end this meeting.
Yeah, thanks from my behalf to everyone. It was very nice workshop with you guys.
Yes, thank you everyone that attended, and thank you for all your questions.
Thank you.
Bye.